Hi and Assalamualaikum. We are from Group 2. Today we will do our last video presentation. So first for assignment 2, which is road sweeper cut clean innovation. So firstly we introduce ourselves. My name is Muhammad Safwan bin Anuari and my matrix number is 192074.
My name is Muhammad. Nama is 192208.
My name is Muhammad Aiman bin Jumani. My matrix number is 191962.
Okay. So for introduction. So for introduction, we have proposed a concept, a design to the Mesra Alam Senam Berhad company to increase the productivity of cutting grass and road sweeper works by introducing mechanization equipment that is low cost, can reduce the operational cost of the company, reducing the road user complaint and user friendly, and others lah. So to construct this overall system, the critical part has been modeled in the computer aided software, which is SolidWorks, and this critical model has been analyzed by using finite element analysis, which is NC software. Jumani? Jumani?
So we're going to the design concept. So the road sweeper is consists of the fuel engine, wheel, blade, and brush. The important part is the fuel engine, battery, wheel, blade, brush, sweeper, and the vacuum sucker. All the working together as a unit to efficiently road sweeper cut clean. This innovation was driven by electrical and fuel energy source, which is hybrid. This functional part of blade and sweeper vacuum can be adjusted to the horizontal and vertical based on desired condition. This innovation solved the problem from existing lawnmower on the market. Next. So if you can see this at the screen, this is the isometric drawing, which is consists of the plane, side, and the top of the design. Next. Next. So the equation the equation involved of the torque developed by motor. We calculate the torque of the motor shaft cutter, the power, the centrifugal force of the cutter, the bending moment of the wheel shaft. Next, we also uh, calculate the battery capacity, battery life, time of the charge of the battery, and the most important is machine efficiency. Uh, Next.
So now is the result and discussion. So for the first critical part is the blade. Here we can see that the meshing of the blade actually produce 19,867 notes and 9,510 notes. This high number of mesh will give us a better accurate result later. Next. After we done the analysis, this is the result that we get. The maximum deflection, normal stress, maximum stress, strain energy, shear stress. We can see here actually the maximum deflection is actually quite small and it's almost unnoticeable. And next, the normal stress and the principal stress we have here is about 0.85 and 0.89 megapascal. Which is actually much lower than the yield strength of the stainless steel, which the material of the blade. which the blade is safe to be used. After this, we can see the image result of the blade analysis. Next, and next.
Okay, for the brush, this is the cylindrical brush mesh, which is the nodes generated and element generated is 232,434 and 11,809. So the brush we use is static structure analysis with the fixed support at the end of the end of the rod. And so we got the total deformation and also the equivalent stress of the cylindrical brush. The maximum deflection we got is 0.02649 millimeter, and the maximum stress is 0.085699 MPa. So for the butt angle, we use a static structure analysis. As you know, we have to use the transient structure analysis, but I think it's quite difficult for us to do it in the ANSYS. So the butt angle meshes generated, which is the number of nodes is 64,837, and number of elements is 30,550. So we got the result for the butt angle analysis, which is a total deformation and equivalent stress. So for the maximum deflection, we got 1.8273 millimeter, and the maximum stress is 2,842.1 MPa.
Okay, now for the vacuum. For the vacuum, we don't use static structure analysis. We use fluid flow analysis, as we need to analyze the pressure distribution along the vacuum line. So here the machine give 12,762 nodes and 60,278 elements. Next. So here we can see the result of the pressure distribution along the vacuum, and we can see that the pressure is high at the outlet and actually low at the inlet. So we can say that the pressure is low at the inlet. That's all.
Unmute, please. Unmute.
So the conclusion that we get from this design is, which is our design solve the problem statement uh that we get, which is in terms of productivity. This is road sweeper cut clean can do two things in the once time. So the next is in terms of the ergonomic features. We put the damper on the seat to give the comfortable to the user, and the body also prevent from the derbies and the blade. Next, then the body was designed with the new latest style to increase the aesthetic value, beside to protect the user from the dust and foreign substance. Analysis by the ANSYS to the important part, which is blade, gear, brush, and the vacuum, was proof that all the mechanical part in this product have the high quality to use. So that's all from us. Thank you and see you guys later.
Okay, thank you.
Thank you.